Good morning. In this class, we will learn about interrupts. Now, a computer program has only two ways to determine the condition that exist in internal and external circuit. One method is by using software instructions, uh, and the other one is actually the response to hardware signals called interrupts. So, interrupts are nothing but hardware signals that force the program to call a subroutine. Uh, now, software techniques actually use a processor time that could be devoted to other tasks, whereas interrupts will take the processor time only when the action by the program is needed. So, most applications of microcontrollers involve responding to events quickly enough to control the environment that generates the events. So, interrupts are often the only way in which real time programming can be done successfully. Interrupts are generated by internal chip operations or provided by external sources. Any interrupt can cause 8051 to perform a hardware call to an interrupt handling subroutine that is located at a predetermined absolute address in program memory. So, briefly, what is meant by interrupt? It means that suppose that a microcontroller is executing a program according to your software that you have developed. Now, in between, that is while performing this program, if you want to deroute it to another subsection in the same program, then you give an interrupt. So once an interrupt is enabled, what the microcontroller does is that it will stop what it is doing at present, and that is it will deviate from the main program that it is executing. Instead, it will go to a subroutine or subclass in the same program, and then it will execute the instructions written there. And once that instructions written in subroutine is over, it will come back to the main program. That is what a microcontroller does whenever it encounters an interrupt. Okay. Now, 5 interrupts are provided in 8051. Three of these are generated automatically by internal operations. They are timer flag 0, timer flag 1, serial and serial port interrupt. Now, two interrupts are triggered by external signals provided by circuitry that is connected to the pins INTO bar and INT1 bar. All interrupts functions under the control of program. Now the programmer is able to alter control bits in the interrupt enabled register. There are two important registers. In the last class we have studied about TCON and TMOD registers. They are mainly concerned with timing and counting. Similarly, the registers concerned with interrupts are IE and IP. IE means interrupt enabled register and IP means interrupt priority register. Okay, now let us see various interrupts. Um, After interrupt has handled by the interrupt subroutine, which is placed by the programmer at the interrupt location program memory, the interrupted program must resume operation at the instructions where the interrupt took place. That was what I have briefed to you before. Okay, so just understand the concept. Next is timer flag interrupt. These are the various types of interrupts that you may come across while learning 8051 microcontroller. Here, when a timer or counter overflows, the timer flag, that is TF0 or TF1, will be set to 1. Now the flag will be cleared to 0 when the resulting interrupt generates a program call to the appropriate timer subroutine in the memory. Now, what is serial port interrupt? If a data byte is received, then an interrupt bit R1 will be set to 1 in the SCON register. When a data byte has been transmitted, then an interrupt bit T1 will be set in SCON register. Now, these ones will be ORed together to provide a single interrupt to the processor, and that single interrupt is called by the name serial port interrupt. Then these are the two registers, that is interrupt enabled register and interrupt priority register. So IE register and IP register, just like TCON and TMOD, are very important. So you have to write each of the bit configuration and their functions of both IE and IP register. So IP and IE registers are very important. That is their configuration, their bit configurations, and their functions. Okay, that you will have to learn. Now other interrupt is external interrupt. Now the pins INTO bar and INT1 bar are actually used by external circuits. Now any input on these pins will set the interrupt flag IE0 and IE1 in TCON register to 1, and this can be done in two different methods. That is, one is that the IEX flag will be set when an INTX bar pin signal is at a low state. Okay, the other one is that the flag will be set when a high to low transition takes place on the INTX bar pin. Now the bits IT0 and IT1 in TCON program will program the INTX bar pin for a low level interrupt when it is set to 0, and the program INTX bar pin will be set for a transition interrupt when it is set to 1. Okay, so that paragraph, first paragraph, is enough for external interrupts. The next paragraph you can just read through. So the first one is important, the first paragraph about external interrupts. Then about reset. Reset can be considered to be the ultimate interrupt. Why? Because the program may not block the action of the voltage on the reset pin, that is called RST pin. Now this type of interrupt is often called non-maskable. Why? Because no combination of bits in any register can stop or mask the reset action. Okay, now unlike other interrupts, now the PC is not stored for later program resumption. That is, a reset is an absolute command to jump to program address 0000H and will commence, that is, it will start running from there. And now whenever a high level is applied to reset pin, 8051 will enter a reset condition. Once the reset pin is low, internal register will have values shown in the following table. So these values you need not study. About reset, just study the above paragraph. You can skip these values, no need of writing that. Next is interrupt control. At critical times, it is necessary that the program have to inhibit or stop the action of sometimes all of the interrupts. Okay, in some critical times it is necessary that the program will have to stop almost all the interrupts that is running. The IE register will hold the programmable bits that can enable or disable all the interrupt as a group, or if the group is enabled, each individual interrupt source can be enabled or disabled. Okay. Then so regarding interrupt control also, that first paragraph is enough. Then interrupt enable disable, that is, the bits in EI register are set to 1 if the corresponding interrupt source is to be enabled, and it will be set to 0 to disable. Okay, bit EA is called a master or global bit, and it can enable or disable all of the interrupts. Next is the interrupt priority. How does the priority comes? Now register IP register that we have set, it actually determine if any interrupt is to have a high priority or low priority. That is, it is IP register that decides which of the interrupts are having high priority or low priority. Now bits that are set to 1 will give the interrupt a high priority, whereas the ones that are set to 0 will be given a low priority. Now interrupts with a high priority can interrupt another interrupt with a low priority, whereas a low priority interrupt continues even after the higher is finished. Now suppose that two interrupts are having same priority and both of them are occurring at the same time, then their ranking will be as follows. It is IE0, TF0, IE1, TF1. That is, if IE0, all these 5 interrupts come at the same time, then their priority will be given as shown in this number. Okay, first priority will be to IE0, second one will be to timer flag 0, then third priority will be given to interrupt enabled 1, and the fourth priority will be given to timer flag 1, and the last priority will be given to R1 or T1. Now interrupt destination. Each interrupt source will cause the program to do a hardware call to one of the dedicated address in the program memory. So it is a responsibility of the programmer to place a routine at the address that will service the interrupt. Now interrupt will save the PC of the program that is running at the time the interrupt is serviced. Then a call will be made to the appropriate memory location. No need of studying this location. Now the ARET1 instruction at the end of the routine will restore the PC to its place in the interrupted program, and then it will reset the interrupt logic so that another interrupt can be serviced. So that is enough regarding interrupt destinations. Last one is software generated interrupts. That is, when any interrupt flag is set to 1 by any means, then an interrupt is generated unless blocked. This means that the program itself can cause interrupts of any kind to be generated simply by setting the desired interrupt flag to 1 using a program instruction. That is how software generated interrupts work. So here just write a few one or two sentences regarding different types of interrupts. So beginning you have to write what is meant by an interrupt and what is its significance. Then discuss about the various types of interrupts. That is, write their name and just write one or two sentences regarding each interrupt. That is enough. Then in this unit, that is in this unit 3 microcontrollers, the topics that is left is instruction set of 8051, then the other topic is basic programming concepts, then finally applications of microcontrollers. So here regarding these topics, I am not planning to present it in the class. I will just upload the notes in SNMC virtual. So you can download the notes and learn. So among these topics, instruction set of 8051 and applications of microcontrollers are very important. Then whereas basic programming concept, it is very lengthy. I think you can just read through it. There is no need of learning. It is just for your information. So if you want to go through that, you can, I will upload the notes, you can just read through. Okay, it is of least importance when compared with the other two, instruction set and application. So regarding basic programming concepts, it is not important, so you can just read, whereas you must give due importance to the other two topics, that is instruction set of 8051 and applications of microcontrollers. Those two topics are important. Then the last topic in your syllabus is embedded system, but we have already taken it in the beginning of our class, so I am not repeating. So regarding this, study instruction set of 8051 and applications of microcontrollers. Those two topics are important. So with this, we have come to the end of our unit 3 microcontrollers. Okay, thank you.